Today's AI Actually episode is inspired by AI thought leader Nate B. Jones's 6 engineering principles for AI agents. The team unpacks what these principles mean for enterprise teams trying to build, deploy, and maintain reliable AI systems.
Watching models after they're in production is as important, if not more important, than the upfront testing.
Well, garbage in, garbage out, man. It's not hard.
All right. Well, normally it's Happy Friday, but we'll do Happy Monday today since we're doing this on a Monday. And wanted to start out. So first of all, welcome back to, we got Mike and Andy and Stu with us, and I'm Pete here today. And I'll sort of credit Stu for sort of stumbling on this video that we found really pertinent and thought that it might be worth sharing. So, and Stu, while we're pulling this up, maybe you could introduce Nate in this video.
Yeah.
And, what you thought about it.
Yes. So, I consume a lot of this guy's content. I know he passed his content around quite a bit. He's Nate B. Jones. You can find him on YouTube or on Substack as well. And he puts together lots of videos. Most of them are worth listening to. This one went over kind of 6 engineering principles around AI agents that I thought was kind of interesting. Now, his video and his takes in general tend to be a little more technically oriented, but I think, I thought we could maybe break some of his points down and do so in a way that obviously it stays technical, but I think would still have resonance for, more business oriented users. Because I think understanding the differences between traditional software development where it was, software development's all based around logic gates and simple things. And you kind of expect, I put these inputs in, I expect reliably and predictably, I'll get these outputs out, right? And I can string them together infinitely and it'll always be repeatable, always give me the same outputs with the same inputs. And AI is a little different, and it creates some, especially when you start to create these multi-turn agents and things along those lines. So I thought it was some really interesting principles. We listed the 6 out here. The first one, which I'd love to get Mike's take on, because I know he's done a lot of this, is really just how state matters a lot more inside of these systems, and actually memory, right? So, and just how kind of every turn of the conversation in an agentic flow creates more memory, and you've got to stack all of that memory together and preserve that context in order for things to work. So I'd love to get kind of your take on that, maybe explain it and go.
Yeah. Look, I'm on a decent number of forums and things out there about LLMs, and like the number one request people have is just make it so that I can give it more stuff and get better answers out. And I think what that kind of misses is the idea that AI is really interactive. Like what does interactive mean? It means that I'm going to say something and then it's going to say something and I'm going to say something back, and it's going to remember what I said first, right? So memory is kind of fundamental. We sort of use it every day, but we miss it, right? Like if you think about, when the Greeks had their oracles, right? And you would go to the oracle and you would say, "Oh, great oracle, tell me the future." And it would say something really obscure and weird to you. This is very much a one-way thing, right? It turns out to be true, but you have no idea why, and it's not true for the reasons that you thought it would be, right? So AI without memory is kind of like that. It's like you can go to it and say, what should I do about this problem? And it'll give you an answer. But then if you say something about that answer, well, it's going to start all over again, right? It's like 42 in the Hitchhiker's Guide. So this idea of stateful intelligence, I hate it because it's such an engineering way of saying it, right? It really just means that the model has to remember the conversation to refine its work to give you something more useful at the end. And we as people operate with all sorts of memory, right? We have episodic memories. We remember songs differently than we remember math, right? And AI is very much the same way, right? There's long-term memory that it learned at the factory. There's long-term memory that I told it I wanted to always remember. There's things that I just said in the current conversation, and then there's things that my administrator wants it to always know about me that I never even said, right? So all these different forms of memory are necessary to really enrich the experience to make the model useful.
I've been thinking about Andre Karpathy talks about it has interrograde amnesia sort of thing. And have you ever seen the movie Memento? Has anybody seen that
Yeah.
movie?
Yeah.
But to me, that feels like, oh, if you want to know how LLMs work, just go watch the movie Memento. And you have to like sort of leave notes and all these sorts of context sort of around it. Does that make sense to you guys? Is that a reasonable analogy?
Yeah, it totally does, right? In fact, if you think about the process where you're polishing up a prompt, as you're going from sort of, I had an idea and I wrote a prompt, to, okay, I'm going to go live now and it better serve 10,000 people. It is a lot like that towards the very end. You're just making small adjustments, reminding it of subtle things, making sure not to tell it, hey, this one's important after you just said something else is important, if those two contradict each other, right? But putting those in the right sequence, and then of course being able to have an eval that tests the whole thing to make sure that, as presented, it's going to do the job that you want it to do.
Balance though, there's you got to have context, right, in memory of like what's going on, but then you also don't want to be jamming, a million tokens into it every time. Like, how do you?
Yeah, it'll be expensive and slow.
Yeah, how do you
Right?
balance?
It's yeah. Well, I think memory is key there, right? So, in other words, you start by giving it not the million tokens, but you start by giving it what you think is right, and then seeing the mistakes it makes, and then patching that up, if you will, with modifications to that, so that like I did an experiment once. It was really interesting. There was a large project, a research project, to identify motion in video, right? So is somebody walking, or are they running? Are they going in the outdoor? Are they going up the down escalator, right? This sort of a security system. And being able to detect this motion was not an easy job for an LLM. Think about it. It's a series of pictures, and it's got to cross-reference pictures one after the other to figure out whether something is happening or not, right, in that world. And so that's a scenario where if you just try to dump all that information in, you're going to fail. On the other hand, if what you let it do is you show it one and say, make some interesting observations about this, and then show it another, remembering the first one, right, then it's got a chance of building up a series of episodes that ultimately help it conclude, as opposed to dumping it all in at the beginning.
Yeah, I like how Mike uses the Oracle of Delphi. My analogy was the bartender, your favorite bartender. So a little different, but that bartender that remembers your favorite drink, remembers what you like, remembers your favorite stories, and being able to apply creative intelligence on, hey, we have a new special that you may enjoy. But I think the other ditch in the road here, Mike, as we're talking about this, is you have to also have selective forgetting, knowing when to forget.
That's a great point.
Especially as the business changes, what was considered wisdom is no longer wisdom, or even persisting biases that need to be taken out. So it's kind of interesting. There's almost two ditches on each side of that road.
What's the boil it down takeaway for enterprises around this idea?
Yeah, I think so. So I'll start. And I think the biggest thing, again, especially as we get to agent interactions, what you don't want to have is this notion of playing the telephone game. The telephone game, amnesiacs, right? Where everything is starting over. And so being able to persist the right memories and knowing when to potentially move on from those memories, I think is critically important, especially, like I say, as we get to agent interactions.
Yeah, and I would say it's important not to think of all memory as one thing, right? There's long-term things that are important, guardrails, policies, right, that are enterprise, that really aren't flexible. And then there are short-term context things that, hey, this is just what I want to focus on right now. And to think in terms of this idea of, yes, the AI is stateful, but stateful in a way that I'm controlling for each of those different layers.
The last thing I'll add to that is more so we can set up going to the next one, I think, is the interesting implication of these memories, right? And making personalized memories based on the turns of the conversations and things like that, is it gets harder, it's less repeatable in terms of a testing standpoint, right? Around these things. So every user, just like every human you work with, right, has a slightly different set of memories, a slightly different context that they do. So you kind of have to work around that a little bit you're also now dealing with agents that build up their own state over time. You're not starting at a stateless point with each interaction where you can predict exactly how everything's going to happen. So I think that is going to come into play as we, step down the rest of these. So
Yeah,
Andy, I'd love to get your thoughts on this boundless uncertainty,
yeah,
which is basically saying, LLMs are no longer, we're used to deterministic things in software engineering. I do this and it returns that. As we all know, when people talk about stochastic parrots or, other sorts of things, where it's probabilistic based, how LLMs respond to certain questions based off of the inputs that come in. It's doing a bunch of math, calculating probabilities, throwing some dice in the mix, spitting out answers, which is probably the way our brains work too. I don't know. How does that kind of factor in to the engineering side of this?
yeah. No, I love it, and I think this is a critically important topic area. And you're right. One of the beauties and the reason people love LLMs is their creativity. It's also potentially one of their downfalls if you don't bound that creativity. And unfortunately, within the architecture of LLMs, they have a notion of function calling, so that you can almost like, I don't know if you guys ever watched this, Who Wants to Be a Millionaire? Where if you didn't know the answer to a question, you could actually phone a friend. And so, the LLM can actually phone my good friend XG Boost to give me whether that bid's going to win or lose, right? And so knowing when to bound and when to call those functions to get deterministic answers, I think is critically important.
Yeah, absolutely. There's certain things that we can allow the model to be flexible on, right? Did it say increasing or did it say rising, right? These are soft things. There are other things that we want it to be really, really specific about, right? It can't misquote a number, right? We've got to be able to, if the number is 6, it's not 7 or 5, right? So I think this idea of bounding the uncertainty is it's a really good notion. We've been bounding the uncertainty for a long time in all of our traditional QA testing, but the bounds are very, very narrow. It must be, this kind of answer. With AI and general models, you get to open that up a little bit, right? Give it a little bit more flexibility on certain things. Did it do A and then B, or did it do B and then A? It's probably okay either way. But there's other things that where we can't really allow it to be flexible, right? We want it to, precisely reproduce facts, or not even reproduce
where
them,
do companies
give references to them. Yeah.
Where do you see companies sort of making mistakes here?
With the bounding uncertainty, yeah. Well, so this is the classic whack-a-mole problem, right? So what happens is someone will do a demo, an internal in-house demo. Hey, look, I tried this thing over the weekend, right? And then somebody gets excited about it, so then they add a couple more cases and they make a nice PowerPoint and they go to the boss with it. Well, now the boss says, hey, this thing's getting some legs. Let's add a couple more cases and we'll go up the ladder, and eventually it's funded, right? And now we're up and running. The problem is they've never tested the negatives, right? They've never tested the situations that don't work, right? And so this idea of bounding the uncertainties, you've got to be able to say, yes, when I ask these positive cases, I get the correct answer every time, or even better, I get the correct answer a certain fraction of the time, or the correct answer is allowed to be within this range, right? As opposed to saying, no, it must give me this exact answer. If it doesn't, I'm going to tweak it and twist it. When you tweak it and twist it to make exact answers come out, you're breaking other cases that are more general. When you give it a little bit more range to give an answer that's a little bit more flexible, you're actually allowing a lot more test cases to work. And so that's something that people miss out on. The tighter you try to make it exactly do the same thing every time, the less likely it is to do a great job generally on a lot of other questions that you're not asking it every time. That's the mistake
You've been building a bunch of things lately. What's your perspective on this, and where do you feel like people maybe tend to miss it a little bit, and where they could adjust?
There's a key word in here. It's actually underlined on the slide, which is you need to engineer in controls, right? And I think the right way to think about that, which fits with what Mike just said, is you're not trying to control to a specific answer. What you're trying to do is define a bounded space, right, around what's acceptable, right? And so It is that challenge of you want to give enough. One of the amazing things about these LLMs is the fact that they're applying intelligence to it, and you get a little creativity, what you might call creativity in the responses sometimes. And sometimes that's some of the benefits of what's happening, is it thinking, in unique ways about this. But you also want to make sure there's a box, right? So I think what you're really trying to do there is test for cases that are that are outside of that box, as well as put in validations around to assume things. So Mike used the example of the answer six, right? It's not 7 or 8 or 5. Making sure that we get this, making sure that it knows to kind of double check its work with tools typically that you've engineered to validate the conclusions that it's making.
It reminds me a little bit of the band I hired for my daughter's getting married this weekend, and I hired a band, and I want them to be creative where they need to be creative. But when it comes to Here Comes the Bride, I want them to play it right on time and do it the right way.
That's right. That's right.
So,
Yeah, flexibility on that one.
Yeah.
A quick example I've learned on some of the things where, we build a lot of applications that are analytic based. And so, one of the power of the LLM in this case is it can analyze the results of what's coming out. But, one of the things I learned with this is, so you get a big data set. I actually learned that sometimes taking that big data set and then running heuristic, which means, programmatic analysis around that data set and breaking it down into a bunch of bullets heuristically around, saying like, this guy was, this group of people were in the top 10%. We had this growth percentage up or down. We had this sort of thing up or down, not relying on the LLM to have to do that math. So you take these heuristics to deliver these bulleted findings around the data set, and then you give those to the LLM in order to provide interpretive analysis among those bullets. So to pull out, what were the most interesting things from that based on the specific question that the user asked and things along those lines. So is this kind of tuning between when to feed it more engineered type information into the LLM so it can use its intelligence in the best way?
Yeah. So you're not trusting it to sort of do the analysis however it wants. You're making sure that's accurate from your perspective and controlled from your perspective, and allowing it to talk about it however it wants within that boundary.
That's right. And it implies some interpretive analysis too, which is sometimes interesting, right? But you kind of are pre-doing a lot of the math for it.
That makes sense.
If you make it sense there, right? Which is also where these things can, tend to struggle the most is when
in that category, what mistakes people make a lot here is this idea that, you observe a behavior, so then you go modify a prompt with a rule, right? And you tell it, there's a new rule, don't ever do this if that happens, right? Now, what you don't realize is that you just made that rule one time. Now, 10,000 times when that same prompt gets used, that same rule is going to be there because of this one thing you were trying to do. And by the way, you're not guaranteed that the LLM is going to follow it because it is an uncertainty machine, right? So this just goes to my overall statement. If you know how to code something, make it possible for your code to handle that situation. Use the LLM when you don't know how to code it, right? And we're getting to these situations where I love the question that I get a lot, which is, I gave it 100 rules. Why didn't it follow them? Well, because you gave it 100 rules. That's why it didn't follow them. It's sort of like you're stuck in a loop there. I took a picture yesterday. I was on the road. I took a picture. My wife was driving, but there were 2 arrows showing a left turn was the way that you were allowed to go, and there was a sign saying no left turn in the foreground in front of those 2 arrows, right? And if you do that sort of a thing, the model is not going to know what to do, and so it's going to end up violating what your rules are. So if you have a situation where you have flexibility and what you need is rigidity, LLM might not be the case, that you might not be the thing that you want. Maybe you want code. On the other hand, if you have a situation where there's a ton of flexibility and what you need is for the LLM to collate that for you into some actions that are now digitized so that you can take control of it, then that's where you want the LLM to be.
So maybe that's a good into the next topic, which is, I think he talks about fast fail versus subtle failures. And Mike, I think when you first saw this, you're like, well, AI fails like people. So, Andy, I think you maybe kick us off a little bit on your perspective.
It's interesting, yeah, with traditional systems, and again, I'm probably about to date myself, things would happen like blue screens of death, right? You had this catastrophic failure and you knew it was catastrophically failing, where with LLMs, it can be much more subtle. And really, I think to the point of the discussion here, watching models after they're in production is as important, if not more important, than the upfront testing, because over time they drift and they drift very, very subtly. And so I think this is a critical topic. And oftentimes where enterprises fail to see the importance of that kind of post-production monitoring.
Yeah, I think, this idea that you're monitoring not just for whether it worked or not, but the quality of the response is really what's interesting, right? And as you pointed out, that the quality of that response with LLMs can vary based on a bunch of things. It could be the model provider did an update and now you're not getting the same answer that you got yesterday. It could be there was a small tweak in the instruction set or a small tweak in the context, or some of those memories we talked about earlier triggered, it to, kind of go off the rails a little bit and think about things in a way we hadn't planned for. I think that's this evals become so important in this, right? Is in terms of, you talked about, it's really important to do post live monitoring. I think as we get into the next bullets too, that point will come back up again and again. I think, what you need to do is have some baseline of what you expect is a high quality response in a large number of scenarios, and then be able to see if and then, that's something you can then test against to a certain level, right? Setting up through your eval structures.
Monitoring an LLM in production, it's kind of like sitting down to dinner with your teenager, right? You're going to want to hear what they have to say, right? They're going to answer questions and they'll tell you, "Sure, I'm doing great, and this is my grades, and this is." You also want to look at what they look like, right? How are they dressed, and have they slept? Do they have dark circles under their eyes, and are they clean, right? Like this is what evaluation monitoring is. You're looking at the results that the LLM has over time, and you're saying, okay, yeah, did it give you the right answer, but also did it run fast? And was the answer something appropriate? Was it the same as it was the day before? Did it include extra information? Did it take too long? Right? Like all of these things are part of that qualitative evaluation, and that's this intelligent failure detection. So many of the use cases I run into are, and companies will freely admit this, where they're not really even testing the negative situations. They're literally just saying, let me try the same 5 questions, and if it does the same thing, then we're good. Well, no, you got to try the anti questions as well, right? The things that you expect to fail. You got to provoke the LLM to try to make it do things that you don't want it to do. You got to find those boundaries in the conversation so that that when you walk away, that teenager's not going to go do something unexpected just because you tested the things that are known to be working right.
What are obviously the implication here is, hey, you've got to have this sort of test harness that understands how to evaluate the ongoing quality of an LLM. But what does it also imply about the care and maintenance of these systems?
As Andy pointed out, it's got to be a very active process post live in the care and maintenance of this. You need tools to be able to detect these. You need, some of that is running these automated evals where you've kind of planned ahead around things that you're going to run through it, and you're judging responses day to day or whatever to see drift. Some of it is really monitoring the real world activity that's happening, right? And having systems for detecting outliers coming out of that, or for the users themselves to give feedback that you can use a signal to roll things up that are coming up oddly. So I think that's one bit. The other bit, which I think is an important thing not to lose in this topic, and it comes back in some of the later ones as well, is that, it's, again, failures aren't binary. We're used to, like, it passed or it failed. It's quite binary. Now you can have very subtle failures, but then as we're now getting into much more complex agentic design where there's multiple turns, in a particular workflow, or there's multiple agents involved in a workflow, what you learn is those tiny failures, which you might not even care that much about, in any one response, they wind up stacking over a series of interactions, right? Very similar to that telephone game that was mentioned earlier, right? So you're talking about just little tiny errors made. Suddenly 6 turns later, the agent has lost track of what it was trying to do. You know what I mean? And I think that is one of the, and it comes back actually in some of these other points with the live monitoring is you've got to monitor all the turns. You know what I mean? And not just one, so monitoring, not just like, here was my starting point and here was my ending point. How was it? You really have to have visibility throughout that chain so you can decompose where the errors are.
There's a testing paradigm shift, but the other thing I see with a lot of companies is there's an ongoing maintenance and sort of care and feeding paradigm shift that they're like, they're used to this idea of, I have a piece of software, I have inputs and outputs and it works great, and there's very little maintenance associated with it.
It's kind of interesting. It's a combination of, the old school health check where, is this thing up, but it's much more nuanced now. And it's almost like now partially that one-on-one you would have with a junior analyst human, working with them to make sure they're still have the right context and are answering the questions. The worst thing that you can have happen, and this goes directly to your question, is have your users tell you that this is subtly drifting, and it probably has been drifting, misleading humans now. So you want to make sure you're on top of that and ahead of that curve before your users are telling you about it.
Yeah. And sometimes it makes sense to shift to a different model, right? I mean, one of the topics on Nate's video is around this idea of capability-based routing, using what's the right model for the job, right?
This one's definitely it's a pet peeve of mine. That so many people just grab the latest model and literally the ones called latest can change under your feet, right? The providers replace them. So many people just choose a model, not realizing that it matters a ton. If you're writing code, if you're writing language, if you're expecting it to follow instructions, in those old westerns, I remember watching The Magnificent Seven back in the day. If y'all remember that, like there's one guy that's a sharpshooter and another one that's the explosives guy that can crack the safe, and then there's the boss, and then there's always the one that can sneak in wherever he needs to be. Like these models all have very, very specific purposes that they've been trained on, that they've been tuned on. Tens of millions of dollars have been spent making sure that this particular model is able to write really good narrative descriptions, right? Or that it's really nicely able to interact with humans quickly, right? So all these factors matter in terms of choosing your models out there. Like whether it can stream back to you or not, right? In situations where it's running overnight and nobody's looking, I don't need a streaming model. But in cases where a user's sitting there waiting for it, they're gonna hit the big red stop button if they don't get tokens flowing back really quickly, right? So every one of these things matters. And if you choose if you choose the wrong model, or choose the wrong problem, and then you choose the wrong model for that problem, then you have a very small chance of being successful, right? But if you choose them, both of those, correctly, it's like the combination locks. Eventually you're going to get a working solution that's rock solid and works really well. I mean, we wouldn't have sayings like divide and conquer if it weren't important to divide the problem in the right way and conquer it using the right tools, right? Then there's another one: use the right tool for the right job. These are engineering adages that have not changed, and LLMs don't change them. You're still trying to make solutions that are ultimately viable out there. Even in the agentic world, it even introduces another couple of layers, because there are models that are really good at keeping track of a to-do list. And that's exactly what an agent needs to do. If it's going to run on its own for an hour without you watching, you want a really good to-do tracker, right? The same way you would have a project manager in a large enterprise. You want to have a model that knows how to go down that list and check off what's been done and scream about things that aren't being done to make sure that the overall agent is handling it correctly, right? It's another part of this whole capability-based routing that's needed, and it needs to happen. A user may say one thing, and that's going to result in 10 different model turns that may every one of them be a different model, right? And every one of those model turns could be a tool or one or more tool calls, which may end up being 100 different tool calls that are occurring for that one thing the user said. So getting these layers correct is really the way that you get to a scalable solution. And you'll if you want it to autonomously run on its own and do all of this activity, then you're going to need to make sure the unit test, meaning each individual turn of an individual model, is perfect at the job that you have assigned to it.
There is no substitute for deeply understanding the business process where these models are going to be deployed, right? And so that's really what you're talking about, and understanding the nuances of, you wouldn't put Yadier Molina, catcher for the Cardinals, in center field, right? You wouldn't put these models out of position. And so the only way you can really know where to put Yadier Molina is understand his skill set, understand what the models can really do, and understand what center field really means in the business, understand what catcher really means, what are the responsibilities, what roles are they going to play, and then you marry those two things up, and that's really the point you were making.
And I think there tend to be a few ways, I think, to break this down too on the models, just in terms of thinking about it. One is, do you need reasoning or not? Right, is very important in these model selections, and so in every big model company has reasoning models and the non-reasoning models. So the reasoning models are going to go through, the non-reasoning models are maybe easiest to think about. You put in a set of inputs, it starts doing math, and it just goes picking one token after the next and gives you a response. The reasoning model is actually going to first apply some thinking process around the approach that it wants to take before it comes back with a response, which requires extra time and tokens and money and everything else. And so I think that's the first thing to look at. Then the second thing is, what capabilities are you expecting from the model, right? So, and you've got to, one is, how much are you taking advantage of world knowledge from the model, right? Versus kind of what I would call word cell capabilities, right? Like right? A word cell type person would be someone that is really good at manipulating, words or other sort of things quickly, right? Into clever ways, right? That's one thing. The other thing is the person who knows everything about everything, right? And has ingested all of this information about the world. And so there are some simpler models that are much smaller, much easier to run, can even run locally on your PC, that are really good word cells, right? They're really good at just manipulating language. But they might not tell you, what the capital of Albania was in 1547 if it's different from today, right? So because they might not have ingested all of that sort of stuff. So I think that type of, one, just looking at those two angles, then you really get into, Coke versus Pepsi discussions on, which is the best coding model, which is the best writing model, which is things along those lines really come into play for the, maybe that's more like the pitcher versus catcher type analogies. But I think you got to really look at those two or three different things and get a feeling for the landscape that's out there, and then have the technical infrastructure to pull it off, which is, tricky at scale.
Moving on to the sort of the next one, I sort of feel like we may have covered a lot of number 5 and number 3, but maybe Stu, do you have a perspective that sort of would go beyond what we've already talked about?
Yeah, I mean, a lot of my background is in live operations, right? Kind of monitoring systems that are already live and running the technical infrastructure for it. And, typically that's like a bunch of up-down monitoring, gets you a long way in that space. And I think this is just kind of showing, like, as we really talked about in number 3, the failure states are much more non-binary, right? You can, and so you really have to have a much more nuanced way of understanding when things are falling apart. And this really gets harder again when you're adding multi-agents are really tricky in this, right? Because multi-agent flows now are, you kind of give this orchestrator a challenge to solve, and then it might call 3 or 4 or 5 or 10 agents to help solve this problem. And they're going back and forth chattering. And you really got, every agent can be doing its job to a certain degree, right? But this still break down the edges, which I think
Yeah,
gets really interesting. So you
on top
monitor
of that,
those
there's
edges.
the non-functional parameters, right? It's a Britishism that I always love, the non-functional parameters. So things like, how much is it costing, right? So I remember watching some videos about the creation of Manus, and that it's an amazing piece of technology, and how they were very focused on some ratios, between the number of input tokens to the number of output tokens, and how they kind of got to a golden rule. Turns out it was about 100 to 1 in their situation. Also looking at ways to drive up the what's called the KV cache hit rate, which is the KV cache really is just means that your prompts are cheaper to run, right? If you hit the KV cache, that means your prompt is cheaper, and all the things that they were able to do to track that number and drive it down, right? So it's like any metric, you're not going to impact it if you're not measuring it. And this health state monitoring doesn't just have to be, am I getting the right answers out? It can be, am I getting them fast enough? Are the users seeing some fluid interactions as things go? Are they actually clicking on the output that they're receiving? How much is it costing me, right? All these things are super important. And they're the kinds of things that we would certainly measure if we had a department full of people, right? So if we start thinking of, a group of agents working together as a department full of people, think about it. We would, we would hold no punches, making sure that organization was functioning optimally. And that's where it's going with models.
Yeah, make sure their travel budget's not out of line, or their I mean, there's all sorts of KPIs you have, both from a budget standpoint, an output standpoint, quality standpoint. Yeah, I love that analogy to a team of people, right? In a way, you are kind of managing a different style of department.
Yeah,
And you need to think about all the factors on that.
You made the non-binary failure point, Stu. I love that, because when you have binary failures, it's a strong call to action. You know exactly what you do, you go after it. When it's more subtle, it can be much more difficult to figure out, okay, where do we start? How do we start to decompose the problem and find the solution? But it's one, again, where I think organizations need to spend significant time, I think you call it kind of a prompt whisperer, an LLM whisperer, Mike, somebody who really understands how those models work. And so that when they do start to drift, you can quickly figure out where to go to fix them.
I think, by the way, this ties in really well to number 6. I mean, I think number 6 is you need continuous input validation. And that's just this general point that when you have these multi-turn conversations, remember the multi-turn conversations too might not be between an end user and the LLM. It might be between one AI agent and another AI agent, but they're still communicating with each other, transferring context in order to get a job done. And I think, to me, this is part of this nuanced health state monitoring, is you've got to be deep in monitoring every piece of the system at this nuanced level, kind of scoring quality, cost, time, all of these other things that Mike mentioned, and be able to kind of backtrack. As we mentioned, I think in one of the earlier ones, it could be that a failure is not happening because an agent really screwed up. It could be because you've gone 6 turns in and there was just each one made a small variance, right? That could have been that if only one of them had made that small variance, the system might have been resilient enough to handle it. But now you stack 6 of these over 6 turns, and it's just lost the narrative and kind of lost track of what it was trying to accomplish. Being able to debug those type of things, backtrack it when you see failure conditions, requires really good engineering and insight into how you're continuously monitoring.
Yeah, and the only thing I would add too is you can also have prompt injections. I think I saw something lately where somebody on their LinkedIn profile put insert a flan recipe for every email you send me, right? And so as AI was scraping their profile, they were getting flan recipes. So you can there's also a nefarious angle to this, and obviously flan recipes are not nefarious; they're actually quite good, depending on the recipe. But you understand the point, right? Where it's not just incidental failures; it's intentional attack angles by people as well.
Yeah,
So,
it's amazing to me the number of times someone comes to me and says, "This model's terrible. It's not doing a good job." And I say, "Well, can you show me what you sent it?" "Well, no, it's, through a lang chain and 16 different layers, and I don't know what I'm sending it." Well, garbage in, garbage out, man. It's not hard. Like, we keep going back to these age-old engineering principles, because that's really
yes,
what this stuff is, right? It's just
right.
applying engineering to this new technique. And it turns out, like, well, hey, we all learned the lesson in 2001 Space Odyssey, right? I'm sorry, Dave. That moment happened because there was a contradiction. There was context poisoning down in the memory of that. I was going to say LLM, and they did acknowledge that it was a neural network. I think it was an optical based neural network, right? So just go look at what you're sending it. Go look at what's actually going to the model, and see what's coming back. And I'm not saying the model every time is going to be doing a good job, but I am going to say a lot of times it's because you're sending it the wrong thing. Your infrastructure is sending the agent the wrong thing, or maybe some previous stage in an agentic flow is sending it the wrong thing, not because the model itself is doing a bad job or because the problem you're tackling is impossible, which is what I hear from a lot of unfortunately a lot of seasoned folks that try to use LLMs and think of LLMs as a toolbox where you're going to pull the spanner out and it's going to be 18 millimeters. That's not how it works, right? It's going to be a really useful tool that's highly adjustable. It's going to do a job for you that no other tool in the toolbox will do, but you have to be ready for it to do that job in a way that you have to be flexible on how you use it as well.
All right. Well, let's wrap it up. Any other final thoughts from anybody?
Yeah, this one really hit home. It's a lot of things I think we struggle, You go into these companies and you see struggles on it every day, and it's the best practiced way to solve a lot of these is also, continues to evolve as everything gets more sophisticated. So it's timely.
And I think that this kind of an approach helps recalcitrant engineers, and I say that with a lot of love in my heart. It helps recalcitrant engineers accept that this is an engineering discipline, a thing that we need to learn to do well, not something that's going to replace you, that's going to take away your job, that's for junior people to use. No. This is a new engineering component that is to be taken very, very seriously. And at the same time, it leaves plenty of room for people to do their part in the picture to make it whole.
And it
Love it.
definitely requires new skills, a lot of skills that haven't existed
Yep,
before,
new disciplines.
out of the
It's not
humans. Yeah.
it's not a thing you go on the weekend, pick up the book and figure out a couple things. It's not a new programming language. A lot easier to learn a new programming language than it is to learn to use large language models, for sure. Like it's a mental shift, a very powerful one, but it is a mental shift to do that. And the good news, everybody can do it, but you have to embrace a whole bunch of dimensions of flexibility that we really haven't had to have until now.
And with that, I'll just say thanks to Nate B. Jones for his ongoing podcast, that episode in particular, and Stu for bringing it forward. I think it's a great topic, and hopefully the listeners all sort of enjoyed and got a lot out of our unpacking of that and are able to do something with it in their day-to-day work. And so until next time, thanks, everybody.